Good afternoon, students. Today we'll discuss about the most interesting fact about the programming language, that is data types, encapsulation, inheritance, and subprogram controls. As per syllabus, this is your part of second unit, and with this we conclude the second unit. So moving to the topic, elementary data types. As you know, there are various types of data, and to hold the data we need the memory to be defined by the data types that we have discussed already in this PPT or in this slides. And as a elements of OOPS concept, encapsulation, it is a security or protection that provide to the data, and inheritance at object to object relation, and how it will be inherited the property of that particular class to another class. Moving to the next. As you know, all this detail, I'm Ashish, having this much of experience and journal papers published. So today we will discuss about the elementary data type, encapsulation, inheritance, and control sequence with the subprograms details. So now coming to the main part of the today's class, that is the introduction to programming concept. This presentation provides an overview of fundamental programming concept, and we come to the elementary data type. So elementary data type, it is nothing but the way to store a particular data into the memory and the way to access the memory in a same manner, so that data cannot be lost while storing and accessing the data. So this called as understanding data types is important for performing operation and making decision in a program. And data types are used to define the kind of values that can be stored and manipulated in a program. And elementary data types include integers, floating point numbers, characters, and Boolean values. So if we consider the data types, the primary data types such as integer, character, based upon the IDs, these are different types of data types. They occupy different types of memory, different bytes of consumptions, then different bytes of accessing the data from the memory. While naming that particular memory, it's called variables. Then why it is called as elementary data types? Because whatever we are using to store that particular data, that is called variables, and all these things, maybe it's integer, maybe it's character, maybe it's float, these are called the elements of the programming language. And these elementary data types include all the basic data types such as integers, floating point numbers, characters, etc., and Boolean values. What is that Boolean values? Boolean values are nothing but the data type who actually receive a true or false, that is 0 or 1. The way if condition work, the way this particular variable or data type work. These are elementary data types. Moving to the next, the encapsulation. Encapsulation is nothing but it is the protection to the data or bundling of data with the method to operate the value of that particular variable within that function only. That's why it is called encapsulation. It protect the data by encapsulating over it with the member function or methods. Encapsulations is the concept by which it binds the data and the method that operate on a data into a single unit called a class. So why this encapsulation is required? More or less, we need to protect the data, that is called data hiding. Once the data hide into the methods and the object only call the methods and the data indirectly calls by itself, and this improves the data protection or data is hide inside. So it promotes data hiding and abstraction, which improves code organization and maintainability. If we see in Java, we are to print a particular thing, we need to write system.out.println, whereas system is the class, out is the object, and println is the function. But inside the println, there are different variables are there. We need to use that variable, but without knowing them, without uh, giving any harm to that particular data. The data is protected. Then inheritance promotes code extensibility and flexibility. As we know, we need a class. Let's say this is a class from this to this. Inside this, we need a function. I'm not writing the name of the function, I'm just noticing it. It is a parenthesis. We write a function, and within this function there is a variable. And in another class, I just create a object of this class such as C1. So this C1 can have the properties of this class. So I can able to inherit this type of object from one class to another, like one is base class, one is derived class. Suppose this is base class, I can create another derived class. So when I create object of this class, this object can also have the properties of this class, the base class. So this way the inheritance helps us to use the code extensibility. The code written for this class only can also used by this object or this child class. And flexibility means we can use the data of the base class here also. That's why it is called inheritance is the mechanism that allow a class to inherit properties and methods from a parent class. So the base class from where a new class has been generated, that is called parent class, and the new class which one generated, that is called child class, or we can say base class or derived class. So what actually inheritance provides? Inheritance actually provides the code reuse. How the code is reused? If a particular function is declared for the parent class, that function or that method can also be used by the object of the derived class. So that particular function can be reused for that object. As common functionality means it is obvious that if our grandfather it my grandfather is having something, I can use that particular thing. If my grandfather has a vehicle, I can drive that vehicle. Likewise, this functionality can be defined in a base class and inherited by multiple derived classes like grandparent to parent then children's. I think you already know all this thing. You can you have idea of this inheritance and all. Okay, just try to understand. If you define a class, this is a class and this is the object, this is the object. When you derive this class into another class, when you create this object, an object of this class, this particular object can also access the data of this particular class. So this is called parent, this is called child. In some book you find this is base and this is derive. So this is the concept of inheritance. Then moving to the next, sequence control. As the name suggests, sequence control is nothing but it must be in a step-by-step process to control that particular flow. How to control the flow? Sequence control defines the order in which statements and actions executed in a program. In a object-based programming language or object-oriented programming language, we need to call different object, we need to initiate different object, we need the memory to be occupied by that object. So the sequence control is very important to how and when that object can be initiated and that memory can be assigned to that object, and that can be initial by the pointers or memory from which the sequence can be provided and the program can be executed. So it ensures that statements are executed one after another and in order they appear the code. For example, if we take a particular block is there, let's say this is the block, this is open curly bracket, this is closed curly bracket. Okay, these are the statements. So here we know that statements are executed one by one. But in object oriented programming, suppose this is a function, this function can be called by object here, object dot function, and there another function is there that can be called by object dot function 2. So this particular function can be written anywhere and this particular function can be written anywhere, so that object can call the function according to its requirement and the statement can be executed one after another in between. But how to execute this particular statement, that can be controlled by the sequence control. Okay, next, moving to the next, subprogram control. Subprogram control means, let's understand the subprogram. It is nothing but when a particular program divided into different small program, that small program is called subprogram. We need to control the subprogram just to enhance the readability and maintainability. As in while writing the program, it is recommended and advisable that always write with the indentation so that it looks good for readability. And block structure, this block structure, these are called as that subprogram. When a program is divided into small program, that is called small program. Let's say the very big program is there, that program converted into small program. So the way we control the execution of subprogram, that is called subprogram control. That's why it is called as subprogram control. Involves the use of subprogram function and procedure to organize and modularize code. Now, what is the advantages of this subprogram, writing the subprogram and using the subprogram functions and procedure in organize and modularize code? What is it? It is because it can allow the programmer to write the code once. The code can be written once and it can be used multiple times. So that is the easy thing while we are doing a subprogram control. Nevertheless, in general also we are using this type of subprogram controls in our real life while we are doing. Like we are doing a small work that becomes a big task, big work as a whole. In this way we also able to uh, code the large program by merging small program. So in this way we can able to analyze a programming id by building those small program analysis block, and the analysis by which the small program can be controlled to execute a complete program. Okay, so if you have any doubts you can reach out to me, we'll discuss. This is all about in today's class. Thank you.